Now that we have our new user created, we can create an additional layer of security for our server by creating a cryptographic key pair to log in. The key pair replaces the role of our login password. It reduces the likelihood of success of brute force attacks on our server. A brute force attack is when someone is trying to gain unauthorized access to your system and sets up a script to try different combinations of characters to guess your password. If you're on a Windows machine, you can follow the steps in this lesson. If you're using Terminal on a Mac, please view the next lesson intended for Mac users. First, open PuTTY Key Generator. Remember, we saved this application to the desktop when we downloaded it from putty.org. On the PuTTY Key Generator interface, make sure you select RSA under Type of Key to Generate. For number of bits, type in 2048. Now click the Generate button. Keep moving your mouse around in this blank area to generate the key. So this is the key here. Highlight the entire key. Make sure you get all of it. Right-click to copy. Now create a folder on your desktop and call it Keys. Inside this folder, create a text file and call it Public. Open the text file and paste the key inside. Now save the file and close the text editor. Now back in PuTTY Key Generator, enter a key passphrase. Confirm the passphrase. Do not forget this passphrase, you'll need it later. Once you've entered the passphrase and confirmed it, click Save Private Key. And you're going to save this in your Keys folder. You're going to save it as private. You don't have to enter the extension, it'll automatically be saved as a PPK file. So just type in private and click Save. So now in our keys folder, we have private.ppk and public.txt. Now you can close PuTTY Key Generator. And back in your command console, type exit to exit the current session. Open putty.exe. Load the My Linode session. So just click on it and click the load button. Don't click open yet. We're not connecting just yet. Under the category menu, expand the SSH item and click on auth. Now click browse and you're going to go to your keys folder and you're going to load private.ppk. Okay, now go back to session. Now click open to connect. We're going to log in as user Bob. It's going to say server refused our key, and that's fine. We'll fix that in this next step. So enter your password as normal. Now we need to create an authorized keys file and enter our public key into this file. So type in the following command to create a blank authorized keys file inside a new folder called .ssh. And press enter. Now open the authorized keys file we just created using nano. So you're going to type in this command and press enter. Okay, now open the public.txt file we created and copy the entire key inside this file. Make sure you get the entire thing. And paste it inside your command console. To paste, you're just going to right click. Okay, so the entire key is in there. Don't worry if you can only see a bit of it. As long as you've pasted, the entire thing is in there. Now, exit nano, so press Control X, and you're going to be prompted to save the changes. Make sure you type in Y and press enter. Now type exit to exit this session. Now we're going to reconnect using PuTTY. So open PuTTY. And click My Linode. Click the load button. In the category menu, go back to SSH. Expand it and click on Auth and load your private key. Now go back to Session and click Open. We're going to log in as Bob. And this time you'll see it says authenticating with public key, RSA key, and then a number. Now it's asking you for your passphrase for this key. You're going to enter the passphrase that you configured in PuTTY key generator and press enter. And now you've successfully connected using the SSH key rather than just a plain text password. Now that we have our new user created, we can create an additional layer of security for our server by creating a cryptographic key pair. The key pair replaces the role of our login password. It reduces the likelihood of success of brute force attacks on the server. A brute force attack is when someone trying to gain unauthorized access to your system sets up a script to try different combinations of characters to guess your password. If you're on a Mac machine, you can follow the steps in this lesson. If you're using a Windows machine, please view the previous lesson intended for Windows users. The first step here is to launch terminal. Type in the following command to create a SSH key on your local machine. Once you do that, you'll need to answer some of the prompts. So enter file in which to save the key. You can just leave that as default and press enter. It's asking me if I want to overwrite the key that already exists. You won't get this message because you probably haven't created a key before. I have, so I'll need to overwrite it. Next, I'll need to enter a passphrase for the key. So once you've entered and confirmed your passphrase, I entered the word test 0101. You can enter any passphrase you like. You'll notice that the identification has been saved, and you can see the directory where the private and public key have been saved, and also the files id_rsa, and the public key has been stored in id_rsa.pub. And then the next we have the key fingerprint. You don't need to worry about that, or the key's random art image. That's fine as it is. Now we'll need to log into our Linode server as user Bob to check if we have the SSH directory already created. So I'm just going to plug in SSH Bob act and then the IP address of my server. You'll need to use your server. And I'll just enter the password to log in. And so now I'm connected to the Linode server under the user Bob. Now to see if we have the SSH directory created, we'll need this directory to store our public key file. Run the following command. This will list all the files and folders in user Bob's account. And I do not have the SSH directory, and so I'll need to create it. If you already have it, you do not need to execute this following command. Okay, so I've used the mkdir and then the name of the directory, which is .ssh, to create the folder. And I'll just confirm that it was created by running the ls-all command again. And we can now see the .ssh directory is there. With the directory created, we can exit to terminate the session. So just type exit and press enter. And now we're back on our local host. Next, we need to copy the public key into the .ssh folder on our Linode server. So the public key is on our local machine, and we need to copy it over to our remote server. And to do this, you're going to use the following command. Okay, so this is the command here. And there's some important things you might need to change. For example, if you've decided not to use Bob as your username, well then you'll need to replace Bob with whatever username you chose. Also, you do have to change your IP address because it's not going to be the same as mine. Over here, where it says Bob, you'll need to change it to your username. If you're following along and you used Bob as well, well then you can leave that as is. Now I'm going to press enter. Now it's asking for the server password for user Bob, so I'm going to enter my password. Okay, so we've uploaded the file called uploaded_key.pub, and that should be in our SSH folder now. To confirm that it is, I'm going to log in. I'm going to log back into the Linode server. And I'm going to type in cd.ssh and then ls-all. And we can see in this folder we now have the uploaded_key.pub file. Okay, so I just wanted to confirm that that was there, so I can go ahead and exit. The next thing we need to do is copy the public key we uploaded into a file called authorized keys. Now I did terminate the session, but I should have left it active. So if you've done the same, then just log back in. And then go into your .ssh folder, so type in cd.ssh. And now you're going to run the following command. And press enter. Okay, so the authorized keys file should have been created. So I'm just going to type ls-all, and we can see that the authorized keys file is there. I'll open the file with nano to make sure that the key is inside the authorized key file. And we can see that the key is there. I'll just press Ctrl X to exit. And now I can terminate the session The last step is to log back in to make sure that we're now prompted for our passphrase in order to connect. So let's attempt to log back in. And you can see now that it's asking for the SSH key. And this is the passphrase that we configured earlier in this tutorial. So enter your passphrase. Mine was test0101 and press OK. And you can see that we're now connected using the passphrase. So the entire process was successful. And now you can log into your server using the key pair and passphrase rather than the plain text password. This is a lot more secure. Our Apache web server contains a web root folder. All our website folders and files need to be stored in the HTML directory inside the web root folder in order for them to be web accessible. To navigate to the folder, type in the following command. Here, the www is the web root folder, and inside that folder, we have another subdirectory called HTML. We're now inside the HTML folder, and this is where all our web files need to be stored. To get a listing of the current directory, type in ls and press enter. We can see our HTML folder currently has one file, the default index.html file, which loads the Apache 2 default page when we plug our IP address into the web address bar. So that's the only file that's in there right now. Now return to the home folder. So type in cd /. In order to be able to add, edit, or delete files and folders in the web root folder, we need to have the right level of permission. By default, only root users have permission to add or modify files in this folder. In the next section of this course, we'll be uploading files to our web root folder from our local computer using an FTP agent. Since we're going to be connecting as user Bob, we need to make sure Bob has the necessary permissions to be able to upload, edit, and delete files in the web root folder of our production server. Before we give Bob the permissions he needs, let's take a look at what permissions already exist. Type in ls-la var ww. We can see that 3 lines appear. Each line gives us the current permission structure of a specified folder or file. The first line, represented by the single dot, gives us the permission structure of the current directory, which is the home directory. The next is the var directory, and the third is the www directory. The permission is represented by the drwxr-xr-x. The D here stands for directory. The rwx means user root, as we can see here, has read, write, and execute permissions for this directory. R is for read, W is for write, and X is for execute. The r-x means other group level users have read and execute permissions. The second r-x means everyone outside of root and group users have read and execute permissions. To give user Bob root level permissions for the web root folder, type the following: sudo space chown -r Bob. Now enter the password for Bob. And that's it. The -r will recursively change ownership of directories and their contents to the specified user. In this case, the user is Bob, and the directory is the web root folder. In this lesson, we'll install a graphical desktop environment on our Ubuntu server using the xfce package and VNC server. We will then use a VNC viewer to connect to the server remotely from our local computer. This means we'll be able to administer our server through a Ubuntu graphical user interface. Think of it like attaching a monitor, keyboard, and mouse right to your virtual machine. Before we get started, let's reboot our system, because we've already made quite a number of changes. We can do this right through our existing session. Just type reboot. Sorry, a correction. Type sudo reboot, because we need to have root privileges to be able to reboot the system. Enter your password. You'll be disconnected from your existing session. So if you're on a Windows machine, you'll need to log back in using PuTTY or Terminal if you're on a Mac. It may take 1 to 2 minutes for your system to fully reboot, so if you can't connect immediately after, just try again after a minute or so. So I'm going to close this session window. I'm going to double click on PuTTY. I'm going to load the My Linode settings. Make sure that your private key file is loaded for authentication. So remember, the key is located on the desktop in the keys folder we created some time ago. And load the private.ppk key. Now go back to your session and click open. Make sure you log in as user Bob and enter your passphrase. Okay, since we're back in the system, the server was successfully rebooted, and I'll just expand the console window. Once you're back in, run your update and upgrade commands. It's a good practice to update your system prior to any new package installations. It only takes a minute. Type in sudo apt get update. Enter the password for Bob. Now type in sudo apt get upgrade to install the packages. Enter yes for any prompts. Okay, so that's finished. We've upgraded the system. Next, we're going to install the xfse4 and TightVNC server on our server. So you're going to type in the following command. And press enter. Type Y at any of the prompts. I'm just going to resize the console window just so you can see better. To complete the VNC server's initial configuration, type VNC server. Now we'll be prompted to enter an access password to remotely connect to our Ubuntu server. So make sure you enter a password you can easily remember and verify it. Next, you'll be prompted to create a view-only password. The view-only password will only allow the user to view files but not make any changes. This is great if you're doing things like presentations, but for our purposes, we want full control over the server, so don't worry about creating a view-only password. So just type N and press enter. After that's complete, VNC server completes the installation of VNC. including default configuration files and connection information. Next, we need to do some additional configuration on our VNC server. First, we need to tell our VNC server what commands to perform when it starts up. These commands are located in a file called xstartup. Since we're making changes to VNC configuration files, we need to stop the default VNC server instance that's running on port 5901. To do so, type in the following command. Before editing our new xstartup file, let's back up the original in case we need it later. So to do that, type in the following command. And press enter. Now open the xstartup file with Nano text editor. Enter the following. And press enter. So in the Nano text editor, you're going to enter the following command block. Here, we've instructed VNC's GUI framework to read the user's .xresources file. This file contains important settings of the graphical desktop, such as terminal colors, cursor themes, and font rendering. The third line tells the server to launch XFCE. This package contains all the graphical software needed to manage the server. So once you've done that, press Ctrl X to exit, but make sure you type Y when prompted to save, and then press enter. Next, we need to grant the user, in this case Bob, executable permissions on the xstartup file to make sure VNC server will be able to access it properly. To do that, type in the following and press enter. To be able to easily control our VNC server, we need to set it up as an Ubuntu service. This will allow us to start, stop, and restart the VNC server as needed. First, open the service file with Nano using the following command and press enter. Now inside the text editor, enter the following block of commands. Here we've declared some common settings that VNC will refer to, like username and display resolution. Make sure you replace Bob with your username if you're using a different username. If you've been following along with this tutorial, you're likely using the same one I am. Next, enter this command block. And this allows us to start VNC server and receive feedback on the status of our start request. This command block allows us to stop VNC server and receive feedback on the status of the stop request. This last block allows us to restart VNC server and receive feedback on the status of the restart request. And that's it for the file. That's all we need to put in there. So what we're going to do now is we're going to exit the file. So press Ctrl X. Again, make sure you save the changes, type in Y when prompted, and then press enter to write to the file. Now we need to change the permissions of the VNC server file to make sure it's executable. So to do that, type in the following command. And press enter. Now test the VNC server service by creating a new VNC server instance. Use the following command to do this. And press enter. So we've successfully started the VNC server instance. With our VNC server installed, it would be a good time to reboot the system. Type in sudo reboot, enter your password. The system will shut down, and this will terminate the existing session. We'll reconnect in the next lesson after we install our VNC viewer. Now that we have our VNC server installed on Ubuntu, we need to download a VNC viewer on our local computer to be able to connect. For this lesson, we'll download TightVNC Java Viewer. In your web browser, visit www.tightVNC.com. Once the page loads, click the Download Now button in the left panel. Scroll down to Download TightVNC Java Viewer and save this file to your desktop. The file is a zip file, so you'll need to extract it. I use WinZip, but you can also use the built-in Windows extraction utility tool. So I'll just right-click WinZip and I'll extract it to folder. So it'll just create a separate folder on my desktop with the extracted files. And when you open the folder, you should see TightVNC-jviewer.jar. We'll be using this file in just a moment. Before we connect using VNC Viewer, we'll need to establish a connection to our server using PuTTY. So open PuTTY. Click on the My Linode saved session and click Load. Expand the SSH menu, click Auth, and we're just going to load our private key. And go back to Sessions and click Open to connect. We're going to log in as Bob and enter the passphrase. Now once we're connected, type in VNC server to launch the VNC server. With that done, our server is now ready to accept VNC viewer connections. Click on this file and open it. An interface will appear prompting you for a remote host IP and port. Now you'll need to enter your web server's IP address. So mine is 457913670. And I already have that plugged in there. For port, you're going to enter 5901, and then you're going to click Connect. Now you should be prompted for your VNC server password. And we set that earlier during the configuration. So enter your password and click Login. And you should now see the viewer load Ubuntu desktop on your screen. Now that we have our VNC server installed on Ubuntu, we need to download a VNC viewer on our local computer to be able to connect. To connect, we'll download RealVNC viewer for Mac OS. First, visit RealVNC.com. Click the download button. Then click VNC Viewer, and click the download link corresponding to the version that suits your operating system. If you're unsure, click the Apple icon and then select About This Mac on your desktop. And you can see that my version here is listed as 10.11.4. So I'll go ahead and click on the first download link. I'll need to complete some basic information in order to complete the download. Click the checkbox to accept the license agreement, and then the download will begin. Once your download is finished, you can transfer the DMG file over to your desktop so you can access it easier that way. I've already done that, so I'm going to go ahead and close this down. And so here it is. Now, before we attempt to connect to our server using RealVNC, we'll need to make sure that the VNC service on our server has been launched. So connect as user Bob, and then just type VNC server to start the service. Okay, so now the VNC server is running, and we can close our connection. Now, double click on the DMG file and then open VNC Viewer, and then click Open. Over here, you're going to type in your server's IP address, and also type in : and then the port number 5901. That's the port that the service is running on. And click Connect. If you see this message, just click Continue. Enter the password you'd configured when we set up VNC server. And then click OK. And now you can see the Ubuntu desktop. The Ubuntu desktop is easy to navigate through. In this lesson, we'll go over the features that are relevant towards server administration. At the top, we have the application menu. Here we can access a variety of applications, settings, and accessories that come with the package. For example, we have a terminal emulator that you can use to execute command lines on your Ubuntu server. So for example, I can execute an update command. There's also a built-in text editor that can be accessed under the accessories menu. The editor is called Mousepad. We can also adjust a variety of different system configurations under the settings menu. On the desktop, we have a trash bin, a file system shortcut, and home folder. Double-click on File System. Here we have access to many important system folders and files. To access your web root folder, double-click on the var directory and then www. Inside the HTML folder, we can see the index file, which comes default with Apache. Right-click on the index file, and you'll see a menu appears with options to rename, copy, cut, and delete the file. We can also open the file with Mousepad to make changes. Now go back to the var directory by clicking the back button. To view information about or change the privileges of a folder, right-click on it. Select Properties. Under the General tab, we can see the size of the folder and all its contents. This folder has 3 items totaling 11.5 kilobytes. We can also see when it was last accessed and modified. Now click on the Permission tab. Here we can see the owner of a folder. In our case, we've given user Bob ownership of the web root folder and also elevated Bob's privileges to read, write, and execute. And so you can see that in this menu here. We can also see the permission settings for group users and all others. To change the permissions, simply click on the menu and modify the option. Now close the panel. As you can see, administering your server through a graphical desktop environment is easier than doing so through command lines, especially if you're not used to working with command lines. I'll exit the file system. When you're finished working with Ubuntu, click the Close button to terminate the VNC connection. Also exit any sessions you may have active with PuTTY. A good way to add an additional layer of security to your newly configured server is to disable password authentication and also disable root user access. This means that your server will only allow SSH key authentication using the public and private key pair we created earlier. It also means there will be no access granted for the root user, so important configuration files cannot be accidentally or maliciously tampered with. To update these settings on your server, open PuTTY or terminal and log into your server using the user Bob. After you've connected to your server, open the sshd config file using the following command. Now change the following settings in this file. On this line, permit root login, change it to no. And change this setting, remove the comment, and change the value to no. Now press Ctrl X to exit. Make sure you hit Y to save the changes and press enter. Now reboot your server. So we'll give that a couple of minutes to reboot, and then we'll test to see what happens when we try to log in as root or using a plain text password. Our server has now been rebooted. I'll start by trying to connect and log in as root user. I'll type root and press enter. And you can see right away that we're disconnected because we attempted to log in as root. That is no longer allowed. Now I'll try to log in as user Bob using a plain text password and not the SSH key authentication. And again, we're disconnected right away. This time, I'll attempt to log in using SSH key authentication under the Bob user. So I've loaded the private key for user Bob, and I'm going to click open. And now you can see it's asking for our passphrase. And we're now logged in. So we can only log in now using SSH key authentication, which is much more secure. One of the best features about cloud hosting is how easy it is to resize your server as the resource requirements of your web application grow. Although we're conducting this demonstration on Linode.com, the concept can be applied to any cloud hosting provider. You might recall that when we initially signed up, we selected the Linode 1 GB plan. Say we wanted to go from this package to the Linode 2 GB package. All we need to do is log into our account. Under the Linodes tab, click the dashboard link corresponding to the My Linode server. This is the one we want to upgrade. Now click Resize. Select the new package. We want to upgrade to Linode 2048. Next, click the Resize this Linode Now button. The entire migration process is automated and takes about 20 minutes. The system will automatically shut down our Linode in order to do the migration. And we can see the status under the host job queue heading. We can see from the status that the entire migration is now complete. I'll refresh the page. We might need to log back in because the session is probably expired. So we can see under the storage label that our disk size has increased, and we now have 24,576 megabytes free. So what we can do is either increase our current disk size or create a new disk altogether to make use of the new resources. We can also see that our network monthly transfer has gone up to 3,000 gigabytes. And so you can see just how simple the migration process is. It's a good practice to create periodic backups of your server configurations. As you can see, we've put a fair bit of work into configuring our server up to this point. As you continue to work on your server, there's always a chance that something could go wrong. Backups will help ensure you have a point in time to revert back to if a problem arises without an easy solution. Sometimes, server problems are easy to diagnose and repair, but other times it can take days, even weeks, to find the cause of the issue. This is especially true if you run frequent updates on your server. If your web application is fairly complex with many users, you should always test updates on a backup server before implementing them on your live production server. In this lesson, we'll show you how to create manual backups of your server using Linode. The first step to creating a backup is to create a server with the same or higher specifications than the one you're backing up. The main reason for this is you want to make sure your new server has enough disk space to accommodate the data from your old server. Since we'll be backing up our server, which is on a Linode 2048 plan, we'll create another server also on the same plan. Make sure that the new server is in the same data center. Otherwise, the backup process will take much longer. So we'll just give that a minute. With the new server created, click on the dashboard button corresponding to the My Linode server. Click on the Clone tab. Place a check mark next to the configuration profile we're cloning. Don't worry about checking off the disks. When we clone the configuration profile, the disks are included. Now click the Select button here. On the following page, we can see the process is estimated to last 20 minutes. We need to select the Linode that we will be cloning this configuration profile to. So I'm going to make sure I select the new Linode we just created. Now click the Clone button. So under the host job queue, we can see the status of the backup. We can see now that the clone has been created. So what we'll go ahead and do is boot the server. Now go back to the Linodes tab and copy the IP address for the new Linode and paste it in your web browser. Sometimes it does take a minute or two after a reboot for the service to start. And we can see that Apache, the default page, has loaded. So that tells us that the clone was done successfully. Remember, this is an exact replica of your other server. The only difference is the IP address. So you can administer it the exact same way, but just make sure that you use the correct IP address for this server. And I'll just go ahead and rename this. To change the root password of a server, click the dashboard link corresponding to the server. Next, click on Rescue. Under the heading Reset Root Password, type a new password and click the Reset button. Also, reboot your server after you reset the password. Keep in mind that if you've disabled root access on your server, you'll need to enable it again to be able to log in with your plain text root password. In this lesson, we'll explore the role of a DNS zone file. The concepts taught in this lesson are applicable to just about any cloud hosting provider. We'll be configuring a zone file on linode.com. This page contains an example of what a zone file looks like. Up to this point, we've been accessing our default Apache web page using the server's IP address. But normally, we wouldn't want our website visitors to have to enter an IP address to access our site. We want them to be able to use a domain name, like mywebsite.com. This is where the DNS zone file comes in. The zone file contains various records. Each record serves a different purpose. For example, an A record defines the IP address that your domain name will resolve to. The MX record defines the mail server that will be responsible for handling emails sent to your domain name. Earlier in this course, we registered a domain name, mywebdevcourse.com. Of course, you registered a different one, and you'll be using that if you're following along. Now we'll be creating a DNS zone file that points our domain name to our web server's IP address. To get started, click on the Linodes tab. From the main page, you can navigate to the DNS Manager. So click on this tab. The DNS Manager shows a listing of all the DNS zone files you currently have. You can see we have 2 here. If this is your first time using DNS Manager, you won't have any. To add a zone file, click on Add Domain Zone. Type in the domain name that you'd like to create the zone file for. So I'm going to enter the domain name I registered. You're going to enter your domain. Now type in the administrator's email address in the SOA email. Next, select the server you want to apply the zone file to. So this will be the server that actually contains your website. And we're going to use the MyLinode server we created. We also have the option of Linode inserting a few commonly used records for us. Make sure you leave this option selected as yes, so it saves us time from having to add them manually. We can always just remove the ones we don't need. Now go ahead and click Add a Master Zone. As you can see, our zone file has been created with a variety of different records. The first record is the SOA record. SOA stands for Start of Authority. This record indicates that the DNS name server listed here is the best source of data for a specified domain name. So in this case, the name server is ns1.linode.com. So this is known as your primary DNS. The SOA email is the main administrative contact email for this domain. TTL stands for time to live. This setting tells other internet servers how long to cache a particular DNS entry. You can leave this setting as the default, which is 24 hours. This is a standard amount of time for most DNS situations. To make changes to the SOA record, click the settings link. You can make any updates on this form and click the Save Changes button in the event that you do need to make changes. But the default settings are just fine, so I'm going to go back. The next set of records are NS records, which stands for name servers. In addition to our primary name server, ns1.linode.com, we also have a set of secondary backup name servers in case the primary fails. This ensures your domain name remains functional and your emails are still processed if one or even two name servers fail, although the probability of that is highly unlikely. The amount of backup name servers will depend on the hosting provider. Some will have 2 or 3, and in this case, we have 5. The MX record specifies the mail server responsible for accepting email messages on behalf of your domain. So if we had an email such as info@mywebdevcourse.com, the mail server listed here would be responsible for incoming mail and processing it. Since we haven't configured any email service for our domain name yet, we can delete this record for now. So just click the Remove button and then click Yes. The A and AAAA records are responsible for resolving our domain name, in this case mywebdevcourse.com, to our web server's IP address. The A record resolves to an IP address which is based on version 4 of the Internet Protocol, or IPv4. With IPv4, there are 4 sets of numbers ranging from 0 to 255. So in our case, 45, 79, 136, and 70. That is the IPv4 address for our web server. IPv4 addresses can accommodate a maximum of about 4 billion unique addresses. Now this has posed an issue because it's not enough for every device on Earth to have its own unique address. So for this reason, we have the AAAA records, which resolve to the new version, which is IPv6. This is a 128-bit address that allows for hundreds of trillions of unique addresses. And that's what the IPv6 address looks like compared to the IPv4. We have a couple of mail records here, and we don't require them because our server will not be responsible for handling incoming mail for our domain. So in the event that our web server did have a mail service installed, which we haven't configured because mail servers are extremely complicated to administer. So that's best left to a third-party company to handle for you. And we're going to be using the Gmail business mail service or Google mail service to process our emails later in this course. The business service does offer personalized email domain names. So for example, our email would still be me@mywebdevcourse.com, for example. So we'll go ahead and set the mail records for Google Mail servers at that time when we do that. So for now, I can delete the mail records, the mail A records, and the mail AAAA record. Just make sure you do the right one. Another important point to mention is the host name. The reason we have a blank host name and a www host name is because people can access our webpage using only our domain name, for example, mywebdevcourse.com, or using www.mywebdevcourse.com. So by creating a record for each form of these addresses, we ensure that both domain name variations resolve to the correct IP. To make changes to any of these records, just click the Edit button. And here we can make changes and just press Save Changes in the event that you do make them. I'll hit back. Next, we have our CNAME record. CNAME records are used for subdomains. A subdomain is appended to the beginning of your normal domain name. So for example, blog.mywebdevcourse.com or support.mywebdevcourse.com. For these subdomains to point to your website, you need to add them as CNAME records. So say we wanted to add a CNAME record for blog.mywebdevcourse.com. Just click Add New CNAME Record. The host name would be blog, and it would alias to mywebdevcourse.com, and just click Save Changes. And then we have our new CNAME record created. A TXT record can contain any arbitrary text data, up to 1024 characters in length. TXT records are typically used for verification. For example, if you set up a business email with Google Apps, Google will need to verify you own your domain name. Now, in this case, mywebdevcourse.com. So to do this, they'll request you create a text record with an assigned string of characters, and that way they know you own the domain name. SRV records are beyond the scope of this course, so there's no need to make any amendments there. Now that we have our DNS zone file created, we need to log into our GoDaddy account and make changes to the name servers. The domain name servers listed with our domain registrar must match the name servers listed in our DNS zone file. Otherwise, our domain name will not work. Before we do that, let's go ahead and make sure our server is up and running. Click on the Linodes tab and go to the dashboard corresponding to the My Linode server. Click the boot button if your Linode is powered off. And we'll give that a couple of minutes to boot. Confirm that your server is up and running by accessing the default Apache web page using your server's IP address. So I'll just go back to Linodes, copy my IP address and paste it. Okay, so the service hasn't started just yet, so we might have to wait another minute. Okay, so now it's up and running. Once that's complete, we can go ahead and amend our domain name settings with GoDaddy. Visit GoDaddy.com and log into your account. Now expand the Domains menu. Click Manage DNS. Click the Manage button under Name Servers. Change the setup type from Standard to Custom. Now click Add Name Server. Here, you'll need to add all the Linode name servers. So go back to your DNS manager in Linode. Click on the My Web Dev Course zone file. And these are all the name servers you'll need to add. And once you're finished, just go ahead and click OK. And then click Save. So you'll see a message that your request has been submitted, and it'll take a few moments to take effect. So we'll just give that about a minute or so, and we'll refresh the page to make sure that the change was processed. Okay, so we can see that the name servers have been updated. Now, because we only recently created our DNS zone file, it could take up to 24 to 48 hours for us to be able to use our actual domain name. Sometimes it is instant. It really all depends. Okay, so you can see that it's working already. That was very quick. But again, if it doesn't work right away, give it 24 hours and it should be fine. Now that we're finished with that configuration, just go ahead and log out of your GoDaddy account. And you can also log out of Linode. Now that you have your local testing server set up, it would be a good time to set up your live production environment as well. Remember, once you develop the website on your local machine, you'll need to transfer the site to a server which is accessible by internet users. As we mentioned earlier, cloud hosting is likely the best option as a hosting solution for a website of any size. Once we set up our production server, all the websites we create will be hosted on this server. When it comes to cloud hosting providers, there are many to choose from. The provider you decide to use will depend entirely on the size and complexity of your web application. If your goal is to create something to the tune of a large-scale digital streaming service for movies, such as Netflix, you would need a highly scalable solution on a very powerful cloud computing infrastructure. Something like this would be best suited for Amazon Web Services, Microsoft Azure, or Google Cloud Platform. Each of these companies have access to the largest data centers in the world and can scale to accommodate the resource requirements of just about any project, regardless of the size and complexity. They also allow the highest degree of flexibility and control of your system. As you probably guessed, these cloud hosting providers are relatively more expensive than some of the other smaller scale cloud hosting providers such as Linode or DigitalOcean. Although their data centers are smaller, they do provide reliable, cost-effective solutions for small to large scale web applications. Their interface is geared towards beginners and much easier to use than the larger competitors. For example, the Amazon Cloud Hosting Service can be fairly complex, even for experienced administrators. Keep in mind that regardless of which provider you decide to use, the server configuration process will always be the same. In this lesson, we'll be configuring a live production server using Linode.com. Linode is a popular, scalable cloud hosting solution for web applications. A server created on a cloud hosting platform is known as a virtual server. Linode refers to virtual servers as Linodes. Other providers use their own terminology to refer to virtual servers. For example, Amazon Web Services uses the term instance, and DigitalOcean uses the term droplet. The concepts explored in this section can be applied to any cloud hosting provider. As with most cloud hosting providers, you only pay for what you use. If you're following along with this tutorial, we'll be creating a server using the Linode 1 GB plan. As seen on the Linode.com website under the Pricing tab, the cost of this server is 15 cents per hour. Unless you plan on keeping the server active after the lesson, you will not require more than 2 to 3 hours of usage. Linode also offers a money-back guarantee for accounts canceled within 7 days under the terms of their free trial period. As per the specifications, our server will have 1 GB of RAM, 1 core CPU, 24 GB of SSD hard drive storage, and 2 TB of bandwidth allocation. During the lesson, we will not only configure and administer the server, but also explore how to create backups and upgrade your server with ease using IP reassignment. Remember, unlike shared hosting, there are no fixed contracts or subscription costs. It's all pay as you go. The first thing we need to do is click the Sign Up button. Enter your email and select a username and password that will be used to log in. Next, you'll be required to confirm your email. Once you've confirmed your email, you'll be greeted with this screen. Click on this button here to complete your sign up. You'll also notice that you can try the service for 1 week risk-free using the 7-day money-back option. So that helps for learning purposes. Once you're on the complete sign-up page, you'll be required to provide some information for billing and security purposes. Fill out the required fields in payment details. So you can fill out your billing information. You can enter any promotion or referral codes. You'll have to enter your payment details. You'll need to preload your account with some funds. For now, just select the smallest option, $5, because again, if you're only doing this for learning purposes, you're only going to have the server active for maybe 2 to 3 hours at most. The amount here is used towards future invoices, should you decide to keep your account active for more than 7 days, because within 7 days, you can ask for your money back. So once you've added the payment details, you're ready to begin. Click on the Linodes tab. In this section, you'll find a listing of all the virtual servers you've created. Here we can see we have 2. Since this is likely your first time using Linode, your list will be empty. To create your first Linode, click on the Add Linode button. On this page, you can select the server configuration for your Linode. For this tutorial, we'll be using the most basic server configuration. Select Linode 1024. Next, you'll need to select a location for your Linode. The location typically depends on where the majority of your users will be located. It's normally a good idea to select a server that is in close proximity with your users. This helps maximize page loading speed. Let's leave the default, Newark, New Jersey, for our example. Once you've added your Linode, you'll see your Linode appear in the Linodes list. Linode automatically assigns a generic name to your server. The status will initially show up as being created. You may need to refresh the page for an update on the status. So just give it 30 seconds or so. And once you press the refresh button, you'll see the status changes to brand new. This means the server has been created. Next, you can see the plan that we selected for this Linode, the 1024 plan. We can also see the IP address that's been assigned to this server. The IP address is very important. Until we attach a domain name to this IP, we'll need to use the IP to access our server. This is both from an administration standpoint, as well as for previewing our web pages in our web browser. We can also see the location of our server. As we selected Newark, New Jersey, that's what's displayed here. We have the option of enabling or disabling backups. Backups is an add-on feature offered by Linode that automatically creates routine backups of your server. And this is at an additional cost as well. More information about automatic updates can be found at the link below. Later in this tutorial, we'll show you how to create a manual backup of your server using disk imaging at only a fraction of the cost. Under the Options heading, we can view the server dashboard or remove the server. If you do decide to remove the server, you lose all of the server's contents permanently, so do keep that in mind. To change some of the basic options for your Linode, click the dashboard link. In the submenu, click the Settings link. Here you can change your automatically generated Linode label. I'll change mine to My Linode. You can do the same. You can see that the label has now been updated to My Linode. It helps keep your Linodes more organized rather than using generic names, which are hard to remember. Now go back to the dashboard and then back to Settings. Under the second heading, you can enable or disable the shutdown watchdog. This automatically restarts your Linode if it unexpectedly powers off. It's a good idea to keep this enabled to ensure your server is not down for long periods of time. Under the Email Alerts heading, you can customize the types of alerts you receive. For example, by default, you will receive an email alert if 90% of your CPU usage has been utilized. And you can see there are a number of others, and you can enable them or disable them by simply ticking the checkbox. In this lesson, we'll attach a disk to our server and install a configuration profile. Click on the dashboard link corresponding to your newly created Linode. Under the dashboard heading, we can see the configuration profiles we have attached to our Linode. We currently have no configuration profiles. A profile refers to things like your server's operating system and configuration. We have the option of creating customized configuration profiles or using pre-built packages. Creating new configurations from scratch can be quite technical. For the purpose of this course, we'll be using existing configurations which are available under the Deploy an Image link. Click on this link. To deploy an image, we first need to select the operating system we want to use. Beside the image label, select Ubuntu 14.04 LTS. Ubuntu is a very popular Linux-based distribution that is widely used for hosting web applications. It's known for performance and security. The LTS stands for long-term support, meaning this version of Ubuntu is considered stable and also regularly updated. A new LTS version is released every 2 years and comes with 5 years of support. Next, we need to specify the deployment disk size. Similar to your home computer, the disk or hard drive stores the data and operating system on your server. We need to specify how much space we want to allocate for the operating system. With Linode, it's possible to create multiple disks that serve different purposes. Note that the total size of all your disks must equal the allowable maximum under your existing plan. For our purpose, we'll just keep everything on a single disk. This includes our operating system and web files. So we'll leave the default setting. A swap disk allows us to allocate a portion of our hard drive space as RAM. Leave the default setting for this option, 256 megabytes. The root password is very important. Recall that a virtual server is stored in a data center. We do not have physical access to this data center, so all our server administration is done remotely. In order to make administrative changes to our server and its configuration, we need root access. For this, we must set a root password to log into the system. Make sure the password is secure and one you'll remember. Once you've completed these steps, click the Deploy button. You'll be directed back to the dashboard, and in this section under Host Job Queue, you can see the status of any pending requests. So disk create from distribution is currently ongoing, and create file system as well. Now they've both been completed, so we see the success label next to each item. The Linode dashboard allows us to perform a number of actions on our server. Under the dashboard heading, we can see a listing of all our configuration profiles. We can edit or remove them as well. Removing a configuration profile will permanently delete all the disks associated with the profile. To the right of our dashboard table, we can see a server status panel. This tells us if the server is on or powered off. Since our server is powered off, let's go ahead and turn it on by clicking the boot button. In your host job queue, you'll see that we've sent a system boot request, and we can see the status bar. So the system has now been booted. Under the disks heading, we can see a list of the devices that are attached to this configuration. We currently have 2 items, and each can be edited or removed. Once a disk is removed, all its data is permanently deleted. We can create a new disk only if we have available space under our existing plan. To check the amount of disk space you have remaining, check under the storage panel. We can see here that we've allocated all the free space in our existing plan to our current disk. In the network panel, we can monitor how much bandwidth we've used out of our allocation. So our total allocation is 2,000 gigabytes, and we can see the incoming, outgoing, and total. Under the graphs heading, there are a number of graphical illustrations for CPU and bandwidth usage. The data will become available once there's activity on your server. Now remember that while your server is running, you are charged the hourly rate for your server. To turn off the server, click the shut down button. You can also restart the server by clicking the reboot button. When your server is off, you are no longer billed. Under the Remote Access tab, we have some very important information. First, we have the SSH username to log into our server using the root account. You'll understand more about this as we progress through the lessons. Next, we have our server's public IPv4 address, IPv6 address, and default gateway. The DNS resolvers help ISPs and institutional networks resolve our IP address or domain name to the correct web server. Linode gives you the ability to create a private network using multiple Linodes. This means you can transfer data from one Linode to another over a local area network. This feature only works with Linodes that are housed at the same data center. There are many practical uses for this, including database replication and backups. Data transfer between servers on a local area network is much faster and cost-effective. For now, don't worry about adding any private IPs, because we'll only be working with one Linode. Console access allows us to use Linode's web-based command consoles to create remote connections to our server so we can administer it. Although this is convenient, it lacks many of the features available in locally installed consoles such as PuTTY for Windows and Terminal for Mac users. Although we won't be using the web-based consoles, let's test the connection by launching the Glish console. You can see a success message indicating that we're connected at the top of the pop-up window. And you can just press any key and you'll see that it requests that you plug in your login information. So remember that our login is root So we'll log in as the root user and type in the password you'd assigned earlier. And now we're connected. With our connection tested, let's exit the web-based console, and we'll see you in the next lesson. In order to administer our Linode server through our local Windows computer, we'll need to download a couple of tools. We need to download an SSH client known as PuTTY and an RSA key generation utility known as PuTTY-gen. To do this, visit putty.org and click this link here. Now download these two files, putty.exe and puttygen.exe. Once you've downloaded the files, move the files puttygen.exe and putty.exe onto your desktop for easy access. We'll be using these quite a bit. In order to establish connections to a remote server using a Mac computer, you'll need to use Terminal. Terminal comes pre-installed with your operating system. To open Terminal, click the Finder icon, click Applications, click Utilities, and then double-click on Terminal. To terminate a session, simply close Terminal. Before we get started with working on our server, it's important to understand why we're using a command console and command lines to administer our server. Whether you're on a Mac, Windows, or Linux computer, you're probably used to navigating your way around using a graphical user interface, such as your desktop. We're used to seeing icons, applications, and conducting day-to-day computing operations visually. When we create a virtual server with any cloud hosting provider, we've essentially created a computer that is located in a remote location and installed an operating system. In our case, Ubuntu. Ubuntu is a Linux distribution, and it too has a graphical user interface. The only problem is we can't hook up a screen, keyboard, and mouse to our server because it's not physically accessible. For this reason, we need to communicate instructions to our remote server using command lines. Just about any action you can perform with the mouse and keyboard on your home computer can be done through command lines. Be it browsing folders, deleting, copying, or even editing files. We can do much more. These are just a few examples. Though it might sound difficult and time-consuming, using command lines is fairly easy. We'll explore many of the commonly used command lines in the lesson to follow. Another bit of good news is once we're done our initial setup using command lines, we can install a remote desktop service on our server to be able to see our Ubuntu desktop GUI and navigate our way around the same way we would on our home computer. In this lesson, we'll connect to our Linode virtual server using PuTTY. First, log into your linode.com hosting account. We'll need to use the IP address found here to connect. Note that your IP will be different from mine. Now open PuTTY. Copy the IP address and paste it into the hostname field. Leave all the other settings as default. So make sure your connection type is SSH, port is 22, and for the last option here, close window on exit, check off the third option. Save these connection settings by typing a name into this field. So I'll just call it my Linode, and I'll click the save button. So these settings will be now permanently saved in our PuTTY interface. Once you've done that, click Open. When you see this security alert appear, just click Yes. Now you'll be prompted for your username. We're going to log in as the root user, so type in root. Next, you'll be prompted for the password. Enter the password you configured in your Linode control panel and press Enter. Once you've successfully logged in, you'll see a welcome message appear. If you've forgotten your password, view the lesson in this section titled Changing Root Password. In this lesson, we'll connect to our Linode virtual server using Terminal. First, log into your linode.com hosting account. We'll need to use the IP address to connect. Locate the IP address corresponding to the MyLinode server. Now open Terminal, type in SSH, and then your username, which is root. After the @ sign, type in your IP address, so that will definitely be different from mine. And press Enter. Now you'll be prompted for your password. Enter the password you configured in your Linode control panel and press Enter. If you've forgotten your password, view the lesson in this section titled Changing Root Password. If your login attempt was successful, you'll see a welcome message. And so you can also see that we're logged in as the root user. With our connection established, we'll go over some essential basic commands in administering our server. I'll just go ahead and maximize the window. The first set of commands are known as maintenance commands. These commands are specifically used to keep our server secure and up to date. It's important to run these commands periodically on your server to make sure that all necessary security updates are installed on your system. The first command we'll execute is apt-get update. Our system is compiling a list of all available updates and new packages that need to be installed. Once that's done, we need to install the new packages that are available. To do that, run the following command: apt-get upgrade. You may be prompted at certain instances. For example, right now it's asking me if I want to continue. Just type in Y and press Enter. So as you can see, there's quite a number of upgrades being performed. So now we've updated and upgraded our system. The system is completely up to date. Now that our server is updated, let's explore some of the file and directory commands. First is the pwd command. This command gives our present working directory. Type pwd and press Enter. As you can see, we're presently in the root directory. The reason we're in this directory is because we're logged in as the root user. By default, we're placed into the directory corresponding to our username. Later, we'll create and log in as another user. You'll notice our default present working directory will be different when we log in as the new user. The next directory command is the ls command. This command gives us a list of all the files in our current directory. Type in ls and press enter. You'll notice that nothing was outputted. This is because the root folder is empty. Let's navigate up one directory. To do that, type in cd space ... Now type the ls command again and see the output. We can now see several folders, including our root folder. We're currently in the home directory. We cannot go up past this directory. To navigate to a specific directory, type cd and then the name of the directory you want to navigate to. Let's go to the var directory. So I'll type cd space var and press enter. As you can see by the extension, we're in the var folder. A quick way to get back to the home directory from any folder is cd space / and press enter. We're now back in the home directory, and to confirm this, we can use the ls command again. You'll notice that our command console is filling up with command lines. To clear the console window, type reset and press enter. This clears the console, but it doesn't delete your previous commands. If you scroll up, you'll see that all your previous commands are still there. Those are the main commands we need to know for now. We'll explore others as we progress through these lessons. The next thing we need to do in our setup process is install LAMP stack. LAMP stands for Linux, Apache, MySQL, and PHP. Since the purpose of creating our web server is to host our web applications, we'll require these services. To begin, type in apt get install lamp server and press enter. Type in Y when prompted. Here, we need to enter a password for the MySQL root user. Make sure you remember this password or store it in a safe place. After you've typed in your password, press OK or press enter. Repeat the password. Once that's complete, we need to install the required Apache utilities. To do so, type in the following: apt get install Apache 2-utils and press enter. Now we'll need to install phpMyAdmin. Type in apt get install phpMyAdmin. Type Y at the prompt. When this message appears, press enter. Make sure that Apache 2 is selected. Select yes at this prompt. Type in a password for the database's administrative user. You can use the same password all the way through, just so that way you will remember it and you're not required to store so many different passwords. Here we're entering the MySQL application password for phpMyAdmin. And now we're just confirming the password. Next, we need to link phpMyAdmin to Apache 2 server. To do that, type in the following and press enter. Now we need to restart the Apache 2 service, so type in okay, and that's it. LambStack is now installed, and we can test to make sure our install was successful. To do so, you'll need to type your server's IP address into your web address bar. So this is my web server's IP address. I'll just copy it, and I'll paste it and enter. So you should see the default Apache page displayed. This is what it looks like. Also, test to make sure that phpMyAdmin works, and to do that, just type in /phpMyAdmin at the end of your IP address and press enter. Now for the username, type in root and type in the password you selected during the configuration. And then you should be logged in to phpMyAdmin. So if both those things are working, it tells you that your installation was successful. And I'll just reset so it clears up our command console. The next part of the process is to give our server a host name and also update our server's date and time settings. A host name is just another name for the server. It has nothing to do with your domain or website name. We could call the server anything we like. For example, you could name it after a planet or even your favorite car. We'll go ahead and name our server Saturn. To do so, type in echo Saturn in quotes greater than sign space etc/hostname. Now type in hostname space etc hostname, and that'll save the setting. Now we need to edit our host's file. Ubuntu comes with a built-in text editor called Nano. So to open your host file in Nano, type in nano etc hosts. And this is the file. Press the down arrow key twice and press enter. Now you're going to type in your IP address, your server's IP address. Press tab and type in the host name. And that's it. Now to exit, press Ctrl X. You're going to be prompted as to whether you want to save the changes. Type in Y and press enter. Now we'll set up our server's date and time zone. Type in the following: dpkg-reconfigure tzData. An interface will appear where you can choose your geographic area. I'll select US, and for time zone, I'll select Eastern. So you can see that the local time has now been updated. It's Monday, February 8th, and 10:50. So that's it. We've now set up our host name and time zone for our server. To confirm that the correct date setting has been applied, type in date and press enter. And you can see the date displayed once again. Now just type in reset to clear the console. In this lesson, we'll be creating a new user account. The reason we do this is because using the root user account is quite dangerous for day-to-day administration of the server. The root user has the ability to delete critical system files. When using command lines, it's easy to mistype a command and accidentally delete or edit an important file. This will cause your server to stop running correctly and potentially cost you a lot of time and resource to repair the problem. By creating a non-root user, we can avoid costly mistakes because by default, non-root users do not have the same administrative privileges as root users. Another advantage is that we can temporarily elevate non-root users' privileges by typing sudo in front of our command lines. To add a new user, type the following: add user, and then the user name of the new user. So we'll call this user Bob and press enter. Now we'll have to enter a new password for this user. We'll have to re-enter it. You'll be prompted to enter some additional information for the user. Just leave it blank and type in enter, 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 and type in Y at this prompt. And that's it. The new user has been created. Next, we need to add the new user to this sudo group so we can elevate the user's privileges when needed. Type the following to do so: add user Bob sudo, and press enter. And so that's it. We've added the new user and given the user the ability to elevate their privileges when needed. Now that we have our new user created, we no longer need to use the root account. It's always a good idea from this point forward to use the new user's account. So type in exit, and this will terminate the current session. Now we can log back in as our new user. So because I'm on Windows, I'll be using PuTTY. If you're on a Mac, you'll be using Terminal to log back in. So I'm going to load the settings for my Linode. Remember, we saved it earlier. Just highlight it and click load and press open. Okay, this time when prompted for the login, you're going to log in as Bob. Now enter Bob's password. And so now we're logged in as Bob.